And welcome viewers to the Daily Space Weather. As you can see over there, we've had another X-Class flare event. Super exciting stuff coming at you. We're starting things out by showing you some ionized carbon. It's 1600 angstroms SDO 24-hour video there. And again, we just had an X-Class solar flare. How's that for forecasting? That's called accurate forecasting. See yesterday's Daily Space Weather video for details if you didn't see what we said about flare watches. Of course, yesterday's video was live streamed, so we were unable to produce any shorts. Now we'll show you lots more imagery of the sun here. Let's take a brief look at Earth, but first, take it all in right there, folks, and there it goes. Another X-Class event. It was an X1.12 class solar flare right at the end of the video, right there. And so, yeah, really a reduction in sunspot activity, a reduction in solar activity in general here over the past 24 hours. Don't expect that to continue as we ramp up closer and closer to solar maximum. Now, of course, there's quite a scene going on here in Iceland still, as there is some lava fountaining happening there at several of those new cinder cones as new real estate forms. Just a surreal image there. And it looks to me like those are earthquakes happening that are shaking the camera, because it does not look windy enough to shake the camera to the amount that it was being shaken. So pretty sure that those are earthquakes happening there. As you can see, that volcanic gas and ash there is not being blown around by heavy winds. So pretty sure that those are earthquakes affecting the camera doing the live stream. Yes, that is a live stream, by the way. You can check it out yourself if you like at Live from Iceland webcams. There's a great view of that long fissure. And let's see what else is erupting as far as volcanism. Askja, a seismic swarm going on there. So another volcano possibly fixing to erupt there in central Iceland this time. Mount Ibu also erupting, Semeru, Merapi. Don't forget Popocatépetl, Santiaguido, Fuego, Nevado del Ruiz, and Sabancaya. Next earthquakes, there are the past 90 days conveniently displayed for you by volcanodiscovery.com, and here are the quakes of a 5 and greater magnitude for the past 24 hours. So the area there north of New Zealand near Fiji had a 468-kilometer deep 5.0 magnitude quake. Peru had a 5.1. That was also at depth, 146 kilometers depth there. Another deep quake at Afghanistan, that one at 106 kilometers. It was a 5.1 magnitude event. And those are the quakes of the past 24. Now let's head back to our SDO imagery. There is 304 angstroms. And look at the size of that filament in the lower left. It's the Mike Bordage's filament. We'll talk more about filament naming conventions a little bit later in the video. So that's another 24-hour video at 30 FPS. There's 171 angstroms as well. And it looks like we do have a couple active regions there rising in the east. But sunspot number slated to drop once again tomorrow, most likely. So if you're spooked of low levels of solar activity, folks, it may be time for you to get into the bunker. 10.7 centimeter radial flux now down to 171 solar flux units. 171 is the F107. There it is for the past year, represented by that black line. Yes. When in doubt, yes. Space Weather Enthusiast Dashboard is not forecasting any geomagnetic storms or geomagnetic unrest, and we would tend to agree. ESA tends to agree, and so do I. Now, we've got erroneous data here showing really low magnetohydrodynamic pressure around Earth. There's the Earth's magnetic moment from space for the past 4 hours, and that's just not right. The ACE is showing like there might be something wrong with the ACE spacecraft ultimately, because it's showing shockingly low solar wind densities, too low to be believed, especially over a period of 48 hours. So these are just erroneous. The space weather modeling framework, it is based on the active spacecraft. So if the active spacecraft is telling the space weather modeling framework that we have 0.1 protons per cubic centimeter for solar wind density for the past 48 hours, you're obviously going to get very low amount of magnetic perturbations. Again, that's not what's happening most assuredly. So just disregard those geospace magnetosphere movies. KP is 2, KP2, so not exceedingly calm conditions, just kind of normal conditions there. KP2 is the average of global geomagnetism, and there's that erroneous spacecraft for you. Look at that, showing like 1/10 of a proton per cubic centimeter for an extended period of time there. So that is not likely correct. Let's hope there's not damage on the ACE. It's showing a very high speed and a very low density. Oh no, normal speed and then erroneous. Erroneous, I tell you. So looking at the Discover, this is a little bit more believable here. 11.4 protons per cubic centimeter for the density. Solar wind velocity here, 412 kilometers per second. I can get behind that. Hey NASA, switch the active spacecraft to the Discover to create a space weather modeling framework that looks like reality. Next are our GOES magnetometers. They're measuring the magnetic field in the outer portion of the outer Van Allen belt at like 23,500 miles of altitude. They're way up there. And seeing some little higher readings there from the GOES 18. So, and of course, we haven't seen any big spikes since that geomagnetic storm, and there are certainly some things that go along with that. We'll talk about it here in a moment for Bush minima. First Earth's magnetic moment, the magnetic moments of the heliosphere. So Earth remains in a North Pole magnetic sector, but tomorrow that may change. We are anticipating it to be changing somewhere around tomorrow's video. So South Pole sector boundary crossing coming. Earth will cross a little tiny current sheet in between the two magnetic sectors and be in a South Pole magnetic sector in probably something like 20 hours. I think we'll be there before we do tomorrow's video. Next is our line of sight field plot. And here the photosphere magnetism is depicted in grayscale, B field magnetism in blue, polar fields in green for north and red for south, which brings us to coronal holes. So there's the coronal hole scenario, and let's switch to the SDO. What happened? Here at the Smash News Network, least busted name in news, we like to find out what happened. So we also tell you what's going to happen. Yeah, it's called forecasting. I know it's an insane thing. Wow, forecasting, folks. Yeah, it can be done. I can't believe I have to say that. Yeah, forecasting, it can be done. And yeah, there's quite a lengthy North Pole-oriented coronal hole here, just rotating past the Earth strike zone with most of it. So that is North Pole magnetism. So let me sort of illustrate that. This is North Pole right here, and these are South Pole coronal holes. South Pole, South Pole, South Pole. So that's the polarity that's going on in terms of coronal holes, which brings us to sunspots. So let's look at sunspot number first. And there you go. And the current sunspot number is 101 sunspots here, dropping back down below the average. And again, we're expecting it to be lower once again tomorrow, assuming none rapidly form or rise. Here's our flare probability monitor and scoreboard. And as you can see, the likelihood of an X-class solar flare remains. So these are facts. These are facts. Deal with them. Deal with them. Yeah, so there you go. That's what's going on in terms of flare probability, and the likelihood of an X-class solar flare is almost 75% at one point during that little run there. Very high likelihood of an X-class solar flare moving forward. So don't think that having one alleviates the likelihood for more, because that ain't the way it works. And here are sunspots. And we're going to just look very closely here at sunspot 3615, the star within a star. And it may have degraded a little bit since yesterday, but again, it is moving closer and closer to the limb, so that very high likelihood of X-class solar flares remains. Having only seen one in the past 24 hours, don't be surprised to see more. And next we'll move to cosmic ray flux. Yeah, cosmic ray flux. Are you familiar with a 4-Bush decrease? 4-Bush decrease happens when we have a CME impact. The solar plasma and associated magnetic fields, they sweep away the cosmic rays, causing a sudden decrease in cosmic ray flux measured at planet Earth. This is called a 4-Bush decrease, and we just had a massive one. So let's take a look at it. We'll crisscross the world, showing you all the different cosmic ray monitors that we regularly show on the channel, and you'll see that huge decrease there in most of the monitors. So first is DOMB Antarctica, and check it out. Here's that geomagnetic storm. We saw a rapid KP8 happen and a huge 4-Bush decrease. DOMC Antarctica showing that same 4-Bush decrease. In fact, all the monitors are showing it, at least the ones that have the data. There's Oulu, Finland. And let me just say something once again that I haven't said for a while. Let me connect some dots for you. Can I connect some dots for you? Yeah, I can. So you see this line right here? Follow this line back. Since that's where we currently are with cosmic ray flux, check it out. We haven't seen levels that low since 2004. Yeah, we're at the lowest cosmic ray levels that we've seen in 20 years. 20 years. That's an indication that the solar cycle is going to be kind of strong. Now, can you use the one to forecast the other one? Well, it's not quite that simple, folks, as the sunspots themselves are not decreasing the cosmic ray flux. It's the solar plasma. So, but that being said, so there's DOMC, DOMB, and Oulu, Finland's 30-day charts. Here is Mexico City. You can see the same 4-Bush decrease right there, coinciding with Earth's rapid onset and rapid drop-off of KP8, a G3 level geomagnetic storm. Next we'll show Athens, Greece. There you can see that 4-Bush decrease at the Athens neutron monitor as well. And then we'll go to way back up north to Apatity and Barentsburg. And Apatity has the 4-Bush decrease. Barentsburg looks like it's seeing some problems. It looks like it's had better days. But there's a great example of those 4-Bush decreases. And let me say again, folks, we are expecting cosmic ray flux to decrease for the coming about 1 year, about a year. Cosmic ray flux tends to lag solar activity by about 5 months rather. So you can expect about another year of cosmic ray flux decrease, as we are still not at solar sunspot maximum. So these are just regular features of the solar cycle, folks. Solar activity is inversely proportional to cosmic ray activity, especially over the longer scale. By the way, if you enjoy the content, press like, press subscribe, press share, leave a comment, etc. Visit the links below the video. We just dropped some new stuff in the Amazon shop. We've also got, you can check out the new logo. You can get it in the Redbubble shop. Help the channel out with merch. And thanks to everybody who has, especially the Smash team. And don't worry, email alerts are coming back. Email alerts will be back shortly. Next, moving into energetic particles and solar flares. The ghost proton flux here, slowly returning to baseline levels. No new spikes in the solar energetic particles. So here's that X-class flare. Again, it was an X1.12 class solar flare. X1.12, folks. Can I get it? It's close enough. X1.12. There it is. So that's the current state of affairs. One major flare. And here come the SDO imagery. So that's 131 angstroms, and we're going to zoom in real tight on sunspot 3615. We'll get another great glimpse of it as it sets tomorrow. And there is the even further zoomed in. And how about one more step? Oh, okay. We'll just stick with that one. And we'll get to solar flare. We'll get to coronal mass ejections next. All right. So, CMEs. But first, some solar system forecast. Before we start talking about CMEs, let's talk about where things are oriented. It's lonely on this side of the solar system. Earth is all alone, but Mercury is coming around to give some company. Here's your 1 week solar system forecast. There's where things will be on the 4th of April. Next is our star chart. This is what's going on overhead where we are. The sun currently in Pisces along with Mercury there, and Jupiter is in Aries, I think, or something. I don't know. I don't care what celestial bodies are in what astrological sign. I just say it for you, the viewer. So, anyway, moving right along, it's time to look at the astronomy photo of the day. This is a great globular cluster. What is it? It's the Omega Centauri globular cluster. Now, a globular cluster could be the remnant of an old galactic collision, but what we know about it is that it is certainly like a miniature galaxy within a galaxy. So globular clusters tend to be roughly spherically shaped, and they have all those stars orbiting a central point of mass. Now, what's interesting about this one also is that it has a lot of red giant stars. So you can see those red, yellow, orange colored stars in there. Lots of red giants in the Omega Centauri globular cluster. apod.nasa.gov. That one would make a pretty good desktop if you're into that sort of thing. Next, coronal mass ejections. And what have we had? Let's take a look. One out of the northeast, one out of the southwest. Another one out of the southwest. They're all pretty weak. Let's see what's been going on here. Did the X-class flare find itself associated with a coronal mass ejection? Maybe. I do see an outflow starting there toward the end of the video. So there may be a CME popping off here. Likelihood of it being earthly directed is kind of low because that sunspot is really close to the limb. Next we'll show stereo A. That's about where it's located, as Parker Solar Probe is near one of its next closest approaches. And remember, folks, each approach the Parker Solar Probe makes, it goes faster and it gets closer to El Sol. Anyway, here's stereo A's coronagraph and difference imagery. And yeah, things have been pretty chill here. What do we have? Things have been pretty chill for CMEs. So let's just cut to our custom CME imagery, shall we? Oh, don't worry, we shall. So there you go. There are things all synced up. And here's a little closer view. We've subtracted the LASCO C3 and added 193 angstroms 60-minute difference imagery. 60-minute running difference, that is. And I don't think those CMEs are earthly directed. What do you think? Let us know in the comments. We're always interested in what you, the viewer, has to say. We do read all comments, even if we are unable to respond to them all. Thanks again to everybody who leaves comments on the channel. That is beneficial to our sustainability, as we've been striving to build a sustainable operation here for pushing 6 years. Anyway, here come filaments. Yeah, filaments are next. They're kind of important. So, but let's do the small view. There we go. How about that? That's not too bad. So, filaments. And of course, the one to really keep an eye on is, and no pun intended, keep an eye on it. Get it? See what I did there? Keep an eye on it. Ha 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 ha. Ho, 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 ho. Ho, ho, ho. Look at that filament in the lower left there, the southeastern quadrant. That's the Mike Bordages filament. And yeah, here's an example of how we name them. We go on Twitter, we put an image there, and then normally I would put an arrow, but this one is so obvious. It's the Mike Bordages filament, x.com/smash-o-mash. Just follow the hashtag name that filament, and you can name filaments after your friends, your foes, or even yourself. So there are the past, the past couple of days there from Cerro Tololo, Chile. And that filament in the lower left is indeed becoming a threat for earthly directed CMEs. That is an absolutely massive solar filament. So fingers crossed that it creates a mid-latitude visible geomagnetic storm. If you're spooked of it, let me just level with you. This channel isn't for everybody because we aren't spooked of space weather on the channel. We don't think it controls our destiny. Successful people control our own destiny. So, get real. Get real. Next to last couple of hours from the Go 16 SUVi. Successful people make our own luck, folks. There's no such thing as a level playing field. If you'd like me to play fair, I'm sorry, I'm unable to do that. Maybe if I was a clone of you, it would be fair somehow. Anything would be fair somehow. But it's not, because that's not reality. Anyway, there are the past couple of hours, and we do have some prominences rising there in the east. No big deal here. Come bonus features starting out with satellite charging hazards, and we have some minor ones there over the northern Indian Ocean. Those surface charging hazards are caused by low-energy electrons building up on the outside of spacecraft. Here's the GOES electron flux here, and coming up off the floor, it looks like NOAA's forecast might be a little bit closer to right. That's the past 3 days. And there we go. There's the past year, conveniently displayed by solon.info/solar. And there is the NOAA forecast right on for that latest forecast. The green boxes are the forecast. The yellow diamonds are the observation. Next to layer where it's measured, the F layer. Here it is in vibrational frequency. And things are back to normal now. So the geomagnetic storm effects are now pretty much completely gone. You don't really see them there, so maybe they're not gone, but they're not measurable as ionospheric vibrations. That's what's going on at about 300 kilometers of altitude. Megahertz, millions of vibrations per second. There's the anomalygram, anomaly in megahertz from a 30-day median, and as you can see, things are looking quite normal once again. We'll also briefly show you the WAM, the whole atmosphere model, the global ionosphere nowcast, depicting total electron content on the left, maximum usable frequency over on the right. And yeah, the right side is for high frequency radio users. The left side is for GPS users. And pardon my face being keyed out. I don't know. I've got space inside my face. So here are the latest intensitygram and magnetogram. Sunspot 3615 has degraded a little bit since yesterday once again, but as you saw, it just produced an X-class flare, and it still has quite a high propensity to do so. So that area, especially the back portion of it, is still magnetically complex. It's still beta gamma delta class. Our favorite kind of sunspots because they're the most likely to produce interesting space weather. Moving on to meteorology, here are the world's stormiest seas. So yeah, welcome to our meteorology segment. We throw this in as another bonus feature because, well, forecasting Earth's weather is far too easy, folks. You've got all kinds of access. You can forecast your weather to your tiny little location on that map with a shocking amount of precision if you understand how the variables relate. The reason meteorologists get it wrong typically, folks, is because they have to forecast for a viewing area. And people who are on like the opposite side of the mountain or something like that, they go, they got my forecast wrong. Well, they probably didn't, but they have to broadcast to a certain area. Otherwise, what's the point? So anyway, those are the world's stormiest seas, and that is off the coast of Argentina there. So those are the highest waves in the world at about 32 feet, which means the world's oceans are kind of calm right now. Anyway, here come our regularly scheduled meteorology segments, surface winds and jet streams of the world. First, the surface winds, and those are what the jet streams look like. So there's the central world. There's the western world's jet streams. Central world's surface winds, and the surface winds of the west. Right? Not bad. Next, our satellite map. That's the visible satellite, part of the NASA GOES Interactive Weather Satellite Suite. Love the visible satellite. It's so good. So good. Just a spectacular view as we bring you the weather from the photosphere all the way down to the troposphere. From the photosphere to the troposphere, folks. That is the range of these videos. Next, sea surface temperatures and the oceans depicted there. That's what's going on. Where's the hottest water in the ocean right now? 85 degrees in the Southwest Pacific. Even pushing 90 maybe, 88 degrees there near places like Papua New Guinea and so forth. Pretty toasty water there as autumn begins with some warm water. Windy.com is where we got that from, by the way. Next, weather.gov, the National Weather Service's homepage. And there are a bunch of weather warnings. If your location is lit on the map, then head to weather.gov and click your location. There are too many counties for us to cover, but here come some forecasts anyway. 72-hour GFS pressure and precipitation is first, as more moisture shows up at California, and then guess what? More moisture shows up at California and just slides down the west coast. Meanwhile, more snow stretches across the western Rockies. And anyway, there's the map, so I'm not going to try to explain it. That's why we have a visual aid. Next, total accumulated precip. And not too bad there, but Washington and California are going to have some flooding in some isolated regions. Once again, it's a 72-hour GFS model. Precipitation totals shown here in inches. Next, our temperature anomaly forecast in degrees Celsius. Once again, it's a 72-hour GFS model for temperature anomaly. Ta-dow. And then lightning. Cuba getting some lightning in the past 10 hours. Besides that, not a lot of terrestrial strikes in the U.S. We may have some. Let's check and see. Southern Georgia, Brunswick, Georgia there. Man, that's looking pretty swampy, right? Anyway, lightningmaps.org. If you've never checked it out, next time you hear thunder, it's highly recommended. Convince the natives that you're Thor or Zeus or something like that. That might be fun. We'll close out with Doppler radar, visible satellite, and water vapor. Yes, water vapor. So first, Doppler radar depicting vertical motion in the air column from ground-based Doppler systems. Visible satellite and water vapor engage. There you go, some moisture making its way across the northern central U.S. Dry air around the Gulf states. Here's your recap to close things out. U.S. Doppler radar for the lower 48. Yes! Visible satellite. And make sure you leave a comment and tell Smash staff that I said yes. Last but not least, there's water vapor. And actually, that's second last but not least. Last but not least is me signing off. So see you next time. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.